Good afternoon, greetings, or good morning, folks. Anybody, whatever time zone you're joining. So this is our webinar series from TechGrid, and the topic we're going to handle today, which has been a hot topic lately in the last couple of years, is this topic of software development team productivity. Should we measure it? Should we not? How do we know whether we have the right tooling in place? How do we know we have the right staffing in place? Are we being most productive? This is a common challenge in my 2 decades or so of working with various engineering leaders. I've found this topic to be has become more of an art rather than science. So that what happens in many organizations is while the sales organization or the customer service has pretty good metrics to know their productivity and how well optimized they are, engineering teams, it is most engineering leaders team to tackle it. Each of them have their own way of reading the tea leaves and figuring out. Sometimes they jump into a new role as a CTO or a VP of engineering of a software company or a IT organization, VP of app dev in a non-IT company, non-software company, and they have to figure out based on their own belief system how to assess the productive nature of the software team. And lately, this has become even more interesting given the AI tools that have come into the use. So that's the topic we'll handle today. And I'm going to say a little more about the topic, but I'm delighted to have Dr. Krishna Kumar with us. He's given a lot of thought to this particular topic, and I thought he would be a best person to kind of have a fireside chat and help kind of demystify some of the debate that has been going around. So that the way the debate works out right now, and I'll keep it short, this preamble, is that a couple of years ago, there was a McKinsey and Company article, and that claimed that, yes, you can measure developer productivity. They didn't even talk about team level. They talked about developer, which is itself a debatable topic. And then there were a bunch of rebuttals from other software engineering leaders in this industry about, oh, this is just not at all feasible, doesn't make sense, and all that. And much debate has gone on in this topic from all credible sources, frankly, in my opinion. And I find as an engineering leader, community representative, this has become very difficult to navigate. Should you? Should you not? If you should, how should you do it? What's the right way? So I thought get Dr. Krishna Kumar here and kind of double click on this topic. We'll cover this topic at most of the time. Then we'll also digress into how this relates to remote teams and all that, which is a relevant topic for distributed software teams these days post-COVID. And then we'll also cover some of the implications of AI tools like copilots and so on, which are playing a role in the productivity. So with that, let me hand over to Dr. Krishna Kumar to introduce himself and share this perspective as a start.
Thanks, Hemant. Yeah, my name is Dr. Krishna Kumar, and I've known Hemant for a long time in many different lives and careers. My background is as a software engineer. I still consider myself a software engineer, and I've been doing this work since the mid-90s, so quite a while, right? I've gone through several cycles of the industry booms and busts, and kind of seen this debate, in various forms for nearly 30 years now, right? So this is not a new debate, and I think my personal perspective from this, about 10 years ago, I started working as a fractional CTO. It was a job between gigs, and then I never stopped doing it. I was basically working as in sort of outside advisor expert coming in to help with operational issues, technical architecture, team structures, and so on and so forth. Just a standard advisory role. And in about like 4 or 5 years, maybe 6 years ago, I really started getting into this notion of, okay, well, we have a lot of this data. How can we use data to actually make this more of a precise thing rather than just my gut instinct? As you said, everyone comes in and has their belief system. How do you go beyond that, right? And so I've been working in this mode, collecting data in my advisory work, using tools and so on and so forth for at least like 5 to 6 years now, right? Build my own tools, build proprietary tools, evaluated tools from the market. And so I think I have a certain set of opinions around this now, about what works, what doesn't work. I'll say it's just at this point, it's my opinion, and I think that it's just one more perspective, but I've been in the weeds in the space for some time now. And so I think the main things I want to sort of talk about here, I think there's still a huge amount of art to this, right? It is not a science by any means, right? And I think the thing for most engineering leaders is there's a lot of noise. There's a lot of marketing. There's a lot of science, so-called science, and research, and there's a lot of pressure because we are in a downturn right now. Our economy, is not what it was, 6 or 7 years ago. Money is scarce. Everyone is really asking, what are we getting for this money we are spending on engineering? So it's productivity, whether we like it or not, is a relevant question that we have to be able to answer, right? And so I think my goal today is to just walk you through my perspective on what I see in the market, and how I see these things being positioned. And if you're going to look at this, how should you think about it? What is your approach? My recommendation: take it for what it is. That is kind of the way I approach this conversation, right? So yeah, hopefully that'll be in line with what we want to talk about today. Yeah.
Absolutely, absolutely. Yeah, that'll be very valuable. I think you have a deep experience and you have surveyed all the debate that has gone on, especially recently. So it'll be very helpful for our CTO engineering leaders to kind of get a kind of curated perspective of how to navigate this.
And I'm also a vocal participant in many of these debates, and so I think I have an opinion.
That's why I thought you would be a great person to bring here.
So take it for what it's worth.
Absolutely. Cool. Yeah. So tell us, should we not? What's the word?
So I think that you have to start with kind of what do you call productivity, right? So I think the biggest problem in this space is that no one really has a clear definition of what productivity is supposed to mean, right? So if everyone calls something different things, right, it becomes very easy to say, I'm talking about this, but not that, right? So I think the two kind of big streams of definition, literally you won't find a definition of productivity anywhere. Nobody actually writes it down, right? And they talk about things, metrics, and so on and so forth. They're writing it down. So I think if you were to sort of look at the two big streams, one is kind of the notion of individual productivity, which is the ability to get for individuals to get their work done effectively, right? And I think that and that's what we all understand. I had a productive day. I got stuff done. That is a very informal notion, right? Everyone recognizes that, right? The challenge is how do you measure it, or should you measure it, right? And then that if you look at that definition, almost everything we do is really around that intuitive definition. Maybe you can lift it up to teams and so on and so forth, but it is about how do you set up the conditions to have the engineers do their best work, right? And I'm going to share my screen here for a second, right? I'm going to give you like this. If you were to measure this, how would you measure it? So for instance, in the DORA State of DevOps report, productivity has a line item in there, right? And it's a survey question. So what basically do you ask survey respondents and say, thinking about the work you do, please rate how strongly you agree with these statements, right? Now, I'm able to do my work, blah, 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 right? I am productive at my very subjective notions, right? If
Hey,
I run this
Krishna,
survey and get back a number.
can you describe, sorry to interrupt, but can you, for anybody in the audience, for some reason, if they have not been familiar with DORA, can you just give that backdrop of DORA?
Sure. Yeah. So, and we'll talk a lot about DORA and in a second, but I'm assuming this is kind of familiar in the engineering space. It is probably the preeminent research organization, the first really, rigorous attempt to sort of think about how to measure things in software development industry at scale in a systematic, scientifically rigorous fashion. So I think it's a very sound organization. Whatever their perspective is on things, I think it's worth considering because it is very influential, right? And they offer the annual report, annual survey of the industry about the state of DevOps, and has a lot of different sections to it: culture, team leadership, engineering practices, software delivery performance, and so on and so forth. And they have a line item on productivity, right? And the line item on productivity this is how they describe it. So if you were to think about how do I measure productivity, okay, here's one approach, right? Ask people, right? Ask people and kind of get an answer. Do you feel productive, right? And this shows you both the benefit and the advantage and disadvantage, right? One is it actually is capturing some useful information from your teams on how they perceive their productivity to be, right? may not be the right thing to do if you're worried about other things about productivity, like, for instance, worried about cost or economics and stuff like that, right? So you have to be sort of go back and say, why am I measuring productivity, right? If it is to sort of get input to improve your internal operations, a survey might be a good way to do it, right? But if you're interested, if your CFO is asking, my engineering spend is now about 35% of my revenues. What am I getting for it? Is that right? Right? This is not going to help you there, right? So I think so. The question is, so these these things are in tension, right? So ultimately, it always comes down to kind of the productivity discussion always come down to this question of, am I talking about economic labor productivity costs, right? Or am I talking about effectiveness of the work? And it's often treated as a dichotomy. My personal philosophy is you need to consider both. They're not the same thing. Obviously, effectiveness, being able to do effective work is important to be able to produce results. But then, you may also need to consider things like cost and so on and so forth. So you need to be able to measure those things as well. We are pretty good on kind of the qualitative stuff. We can measure it reasonably well right now. Not so good at connecting it back to business results, right? So ultimately, that's where we have the challenge because when push comes to shove, the only way we know how to improve productivity is to lay people off, right? So it is not a great place to be, right? Unlike, for instance, in sales. So if I was in sales, I have a really good notion of unit economics, right? I hire a salesperson, pay them something, give them a quota, I can figure out how much revenue they bring in, or I know their productivity, right? If I have consulting, I can, as long as the consultant is working and they bring in revenue, they're productive, right, for the company. So again, the utilization rate is a productivity rate. So there's very natural notions of productivity in many sections, even for knowledge work and even for software and so on and so forth. So depending upon the context, if you're doing product development, for instance, or if you're an internal function in an IT organization, the connection between the work you do, right, and how you sort of impact business results is indirect, right? And that is usually taken as a indication that we need other ways to measure productivity, right? Proxies and so on and so forth. We can't connect it directly to revenue, so we look at other things, other proxies, right? And so that's kind of been the state of the affair. So we, in areas where we're really dealing with kind of a unit cost of labor question, and it's easily kind of attributable. We have tools to do it. People manage labor, utilization rates and so on and so forth. In many industries that can work, right? But product development, internal IT, corporate IT is very hard, right? So the business context matters in terms of how you can measure these things, right?
Yeah. Can you share the bigger perspective of what the recent efforts have been, including the McKinsey work, as well as some of the additional thought leaders who have talked on this topic, and bring a perspective on what the recent efforts have been on this topic, on the team level, organizational level?
Yeah. So I put together this slide that kind of talks about the overall history of measurement of developer productivity in the industry, right? And I don't know if it's easy to read or not, and it goes back quite a ways, right? So I think that even like going back to the 1990s, we had these notions of measuring proxies, because again, when it's hard to measure the direct impact of the work on the outcomes in the business, you naturally lean on proxies and say, okay, well, the first proxies were things like lines of code, function points was interesting. So we like say, well, developers produce code, so we should measure how much code they produce in some form or the other, right? And that was kind of throughput-oriented measures of productivity, right? Which were kind of fairly common in the 90s. They're still common today. Even today, the most modern, latest framework still measures PRs per developer, which is kind of a very much along the same lines of lines of code, even though you can dance your way around the fact that it's not, but it's because the PR. I don't know. Anyway, so we are still talking about throughput-oriented metrics even in 2025. So that stuff hasn't gone away, right? It's part of it, right? But I think the overall, like there was a very influential article from Martin Fowler in 2004, which incidentally was the last recession, right? That's when people start thinking about this stuff, right? What is productivity, right? And so that Martin Fowler's argument was very much along the lines of what I'm doing now, which is like, when it's hard to measure the direct impact, you're tempted to measure these proxies, but these proxies don't really allow you to sort of accurately capture, why that unit of work that somebody is doing is contributing to revenues, contributing profits, and so on and so forth. So they do more or less do more harm than the good, and they're easy to game, right? So if I say lines of code, any developer can game that, right, to make that number go up and down. So they, in the end, they become less valuable, right? And so I think for the good part of, the 2000, 2015, and so on. So up to what, first half of this, first 15 years of this decade, the whole question of productivity was not super important. Measuring productivity is not important. We had thought we had, techniques, better ways of building software, better ways of working that allowed software teams to be, more effective. Agile techniques, XP, Scrum, lean software engineering, introduce efficiency notions into it. Cloud and DevOps came around at the end of the 2010s. Continuous integration, continuous development, deployment. Also, all these tools were there, and the assumption was that that's how you kind of improve productivity. Just put in the conditions to make people be able to work effectively, right? And don't bother measuring productivity at all, right? That was kind of the consensus, I think, probably till like recently, right? When people went back to say, okay, we need to really start measuring productivity again, right? And again, reason because that is because it's about the economic cycle. It's really nothing about intellectual interest in productivity or anything like that. It's really about the economic cycle, right? And so the question is, have the tools that we've developed, in those last 15, 20 years, are they up to the task of actually answering the question that people want, which is, what am I getting out for my money, right? And I think my answer is it's not, but we can do better, right? I think we can definitely do better. And we need to be paying more attention to that question because software is everywhere now. It's not just a pure high margin product business. It's there in low margin businesses. And the question of economics of software development is, is a meaningful question, right? So we shouldn't sort of just hand wave our way and say, nah, it doesn't matter. Just let people do their work and it'll work. It's an actually valuable question to answer, right? So I think that my thinking around this is that we don't have the techniques yet. We are still figuring it out, but it's not an irrelevant question. It's not an impossible question. You have to be able to answer it, right? And most of the work that has happened in the last about 8 to 10 years has really started with Dora, right? So Dora was the first systematic approach to sort of measure stuff in software in a systematic way. And the questions that they were looking to answer were really actually very valuable questions, which is like we've developed a whole bunch of techniques, lean, software management, continuous integration, continuous development, trunk-based development, and so on and so forth. Yet most people are not adopting them, right? So most people, even today, go to a big retailer, they all have code freezes, starting in November, right? Nobody wants to push stuff into production, right? Even today, people are scared of deploying stuff, right? And if deployment is a constraint in your sort of system, then that, causes everything else to be backed up with it. So you can't release, if you can release only once or twice a year, then it limits your nimbleness, limits agility, limits everything else, right? So I think the Dora research was really sort of initially intended to prove that, yes, you can actually sort of do things like continuous integration without impacting stability. You can actually sort of collect data to show that there are people who are doing this, who are deploying 10 times a day or 100 times a day, and their quality is not affected. It was more to build that kind of case, right? And so we started out with, and they started out with looking at this notion of, well, they needed data. The only way to collect that data at scale was surveys, right? And so they used surveys and psychometrics for that, right? And they touched on a lot of things, not just delivery performance, culture, organizational performance, a whole bunch of, so the Accelerate book is the best reference for that. There's a whole set of factors that they were looking to see is what does it make an effective software team, and that research is solid. People should be reading more of it. Unfortunately, one thing I think they did wrong was the Dora metrics, right? Dora metrics, in fact, are the most popular part of Dora that everyone knows, which is the four metrics, right? Lead time for changes, deployment frequency, mean time to recovery, and change failure rate, right? Everyone kind of knows that now, but I think the focus on metrics made Dora what it is today, because it became everyone wanted that handle, right? And the claim was, okay, you have elite performers, low performers, high performers, and there's benchmarks. I think those are all wrong, right? So I think that those are the wrong things to do because it put in place a lot of wrong incentives to take these metrics and turn them into things that you had to meet, right? As opposed to the outputs that you would get if you adopted the practices that they were advocating for, right? And so that's, to me, that was the first kind of the thing where you actually had some industry standard research backed metrics that people started treating as productivity metrics, right? And this is a recurring problem, right? We want metrics, we want to measure productivity. The moment we have something that looks like a candidate, we tend to overuse it, right? And so DORA first, if you use the DORA metrics well, they can be very powerful in terms of improving your operational efficiencies and kind of getting a lot of the good practices that make it easy for us to deliver software in place. It actually does improve productivity, right? But if you just measure DORA metrics as a productivity measure, then you're basically doing the wrong thing, right? And a lot of people do that. They treat that, okay, well, we should start by having DORA metrics and starting with that, right? So I think, to me, that's where the line lies, right? And we'll talk about the other stuff in a second, but why don't you stop for a second, maybe pause to get your feedback and questions.
Yeah, the interest of time, this is a very helpful backdrop, Krishna, that you're sharing of how the industry has evolved and come to this point. Let's speed up our discussion to get to the heart of the issue, which is what should an engineering leader do, given they have to report to the board and the investors of how they're using their investment dollars, the CEO of the board, and they still have to, of course, responsible to the engineering team to make sure the engineering team has a balance in terms of not being overworked, not being having the right kind of a developer experience and all that. So how should an engineering leader think about this topic?
So my answer to this is a bit cynical, right? Because I think that the work that is needed to make a team productive is significantly more than the reporting work that is needed to prove that you're productive, right? And right now, I think a lot of people are really being pressured to sort of give numbers, right? And if you want those numbers, you can produce them, right? I think you can produce them. There's tooling to produce it. There's theory behind this. So there's a whole bunch of, like all the stuff that I show in the back in the back of my thing. In this slide, there's engineering management platforms that will collect data, do metrics, do reports, and so on and so forth. And so I think there is a kind of consensus that there is this set of metrics. So space, is a framework that has a bunch of set of dimensions along which we can sort of measure the qualities of the environment that in which engineering works, right? Recently there's DX Core 4 is another framework. They all give you a way to say, okay, here is the set of numbers that captures our productivity. We can benchmark them against our industry and so on and so forth. I'm personally, I just think it's all theater, right? So I think it is useful to solve the board problem, right? And the board needs numbers, right? And for that is useful, right? I mean, I'm not saying it's not useless, right? Whether or not that'll actually help you sort of turn around your business or not is a completely separate question. And almost none of these tools really sort of touch upon that.
Yeah, so that's a very good
Really
distinction.
Yeah.
That's a very good distinction you draw, which is pleasing the board or appeasing the board by metrics that are, industry standard, looking like DORA and others. But if an engineering leader really wants to get to the heart of the problem, they're incentivized, they know they want to do the right thing for the company and the business, how should they think about actually moving the economic needle rather?
Yeah, so and I think that is the that and to be fair, a lot of engineering leaders are really focused on that too, right? So I think and some of the stuff is kind of a prerequisite for that. You need data. You need to be able to collect telemetry data. You need to be able to collect data from surveys. And there's a whole set of infrastructure you need to have in place if you want to do this systematically, right? The DORA capability list, there's a huge capability catalog here, right? That basically talks about specific capabilities that have been proven to improve specific aspects of your development process, right? And there's data you can attach, measurements you can attach to almost every one of these, right? A program to do sort of systematic improvement. We do have the knowledge on how to do that. I don't think we have enough experience as industry sort of rolling this across systematically and actually making it happen. We're starting to see it happen, but it's still very, very slow, right? So I would say we are kind of in the first phase of having the tooling, having the machinery, having the thought leadership, and people are, in pockets and places and so on and so forth are doing it, right? But it is not yet, I think, mainstream. And I think one of the big things that I always recommend to people is like, the thing I find about all this stuff here is it's very generic. It's very engineering specific, engineering generic, right? I mean, it doesn't talk about what
Yeah.
industry you're in, what's the life cycle of your product, where are you in the product life cycle? Are you a startup versus a mature company, right? I mean, all these questions are very different depending upon where you are, right? So, I think the key thing that you have to have in place is that you need to be able to sort of look at your engineering organization, right? And really be able to sort of identify teams, units of work that connect back to the business. And they're all different because typically most software companies have people working on new product stuff, people working on a core product, people working on infrastructure, right? Productivity for every one of these is different, right? And so having the context of your business, mapping out your teams, doing what we call a value stream map, how they work. There's a whole bunch of work that has to come before you even ask, what should I do, right? And then the question of how should I measure it? That's kind of the third in the list, right? What I generally find is that people jump straight into metrics. What metrics should I
Yeah.
use, and work backwards from there, right? Which is where things fall apart, right? So I think the machinery is in place for us to be able to do many of these things. The infrastructure, is becoming, so there's even open source infrastructure like for telemetry and stuff like that is actually quite good. I mean, I think, you can, and I've built this stuff myself, so I know the space quite well, right? I think the tools are there, right? How to actually sort of build something that works for you, right? That is where all the work is, right? So the context, mapping your environment, mapping your teams, understand the causal drivers. What causes your business to move, right? How does engineering fit in that? What things do I need to change in engineering to move those numbers, right? Just like we do in product, right? We try to understand user behavior and figure out how to change the product, right? An organization is not different from that, right? We have to understand the causal drivers of the work that we do and figure out how do they connect. It could be that if you're an early stage startup, revenue is your only driver you're concerned about, right? But if you're in growth stage, or you're running out of runway, you may want to think about how you can use engineering to reduce costs, right? So you have a lot of different levers that we can apply, right? But you have to apply this with not generically, not look at what Dora is telling your metrics are. You have to figure out how to apply that to your specific context, right? And that's where I think that and a lot of people are doing this, but I think the message that you get in the industry is just follow these rules, just follow these standard metrics, and you will be able to measure productivity. To me, that's where things get wrong, right?
That's a very important distinction you're drawing, which is the context of the stage. In the common context differences are the stage of the company, an early stage software company which hasn't yet, let's say, reached a product market fit, early stage of revenue traction, still figuring out what product to build and not, and the other end of it is reasonably mature companies scaling and now trying to be more efficient in their use of capital for scaling and all that, for use of R&D dollars efficiently. Can you talk about those two typical contexts? What would be an appropriate different metrics or a different productivity measure for each of those two contexts?
Sure. So I think that the concept that I use for this is this notion of leverage, right? So I think the idea is that if you look at the work that somebody does in software, software is very unique, right? In that you can do like 1 week's worth of work and generate like $2 million of revenue over the life cycle of that product, right? It is not linear. The work that you do is not necessarily linear in the kind of returns that you get, but those returns happen over time. There's cumulative returns over time, right? So in software, there is the possibility that you can get nonlinear returns on any given unit of work, right? The leverage that you can provide from kind of working on the right things that pay off versus the things that don't pay off, right? In the long run can be very, very good, right? So if you make better decisions on which things to work on, we tend to sort of still think quarter by quarter. How much did I allocate to bugs in this quarter? How much did I allocate to features in this quarter, right? But we don't think about like how do I sort of do kind of measure the leverage out over the longer terms. So you do need to measure impact. You need to understand kind of, okay, what did I do this week? that, and when did that actually pay off, right? And that is one thing that most companies don't do at all, right? We still think, okay, well, I did 60% of my work was on features this quarter, but how much did that bring me, right? So we don't do that kind of reasoning, right? Uh, Generally, if you're in an early stage company, then I mean, ultimately productivity is not your biggest problem. You're trying to stay alive, right? So I think you want to make sure that you're getting the right products in the market. Productivity becomes much more important when you're a mature company, right? So I think you really sort of have investors looking at your R&D spend versus revenues and so on and so forth. And in those cases, I think there's two ways you can think about it. One is obviously you probably want to invest in R&D to sort of get returns out of it, but that you will measure it differently because you think of something like, how much of the last 18 months, over the last 18 months, how much of my revenue came from new products versus things that are already in the pipeline. So to understand the incremental lift from engineering spend, right? But I think the equally important thing in those companies is being able to use engineering to reduce costs, operating costs, right? So if I, for instance, figure out if I'm an AI company and I figure out how to sort of reduce inference costs by 10%, right? And if that's a piece of work that an engineer does over 2 weeks, the savings I'm going to make over the life of that model is going to be huge, right? So you can actually get high leverage maintenance work, right? High leverage operational improvement work, right? We tend to sort of, regardless of the phase of the company, we tend to sort of think of this as features are good, maintenance is bad, and those are very mature kind of ways. And the vendors actually promote that, right? Most vendors will tell you, yeah, just measure these three numbers and look at the total based on features. It's not the way that's not a smart way to operate, right? You got to be much more cognizant of how much leverage each individual piece of work you do, and then low leverage work. So if you spend most of the time, when I go to companies, very common for them to spend 30 to 40% of their time bug fixing, right? Bug fixing is the lowest leverage work you can do because best case, you're staying neutral, right, in terms of revenues, right? And you got to keep paying that cost every time. So anytime you're doing manual work, anytime you're doing toil, that's all low leverage work, right? Figuring out how to take that low leverage work and convert it into high leverage work is engineering, right? So using engineering to actually reduce costs, make things more efficient, is huge, high leverage work, but it doesn't get recognized because we still think of things in terms of features good, maintenance bad. If you have maintenance, all the costs in software is mostly in maintenance, right? So I think it's more about how you sort of think about the work, what specific options do you have, right? And how do you sort of distinguish between the work that's really providing long-term leverage and figure out how to measure those things. And you have to measure those things. We don't measure them. Which is why you have this trouble, right? And measuring them is hard. Sometimes you actually have to put a plan in place, figuring out how to attribute things, how to track. Just like you measure a marketing campaign, you got to do work, right, to measure it.
Yeah. So let me ask you this question: what you call leverage, is that parallel or similar concept to the diligent prioritization, ROI-based prioritization that some good teams do, which is the value this new feature or this bug fix is going to create versus the cost of fixing it or writing this new feature, and that's the ROI of that incremental effort, and therefore is that same as leverage in your mind?
I think that leverage can be a criterion for this, right? But it's more important to actually measure it, right? So I think that people will say, okay, well, this feature is going to give you more ROI than this other feature, but there's no mechanism in place to figure out, did it actually give you that ROI, right? Impact measurement is something that we don't do at all. Some of the very sophisticated companies do, but it's a microcosm of the whole industry, right? We don't really spend time and say, because again, often the impact is 2 quarters down, right? 3 quarters down, right? Who keeps track of all this, right? So even more important than measuring productivity is measuring impact, right? Because that'll help you make better decisions, right? And ultimately, you need to have a causal model of what causes revenue to grow, right? And you need to understand kind of here are the things that drive revenue in my business, right? They're not generic. It's very specific. This is why this team works with this team, right? So mapping the stuff out, right? Mapping the drivers, having a real model. And I think a lot of I work with a lot of engineering leaders who do this. They do it intuitively, right? But I think that those are treated as kind of one-offs. They're not one-offs. Those should be the normal thing, right?
Yeah,
The one-off should be the kind of where you pull from, the standard frameworks and kind of which one-off do I pull for my business, right? So I think that it's like working from a menu. You have a menu of choices. You have to understand how they fit in your business rather than taking that as a formula and try to fit your business to that framework, right? That was true for agile. That's true for safe. That's true for everything. It's the same problem underlying, same underlying problem.
Yeah. So recognizing the inherent limitations of being able to come up with a revenue estimate for a new feature or a bug fix, which is, like you said, in future, next quarter, next year, you will know how many people are buying because of this new feature, or keep churn is lower in your product because this bug was fixed. That recognizing that inherent limitation, still, should we not then insist that the product management and the product marketing teams who are justifying the backlog and prioritizing what feature to build, they should be held accountable or should hold some accountability to estimating the value, the revenue value, even though it is only an estimate, but at least that.
I think that is kind of part of the problem again, right? So I think the distinction between marketing, product management, and engineering, the silos between them, are a
Mhm.
huge cost of the inefficiency, right? Ultimately, there's no productivity without all three of them working well, right? And we tend to sort of hand things off to each other. Your job is to build the backlog. Your job is to execute on the backlog, right? And that's how we end up with feature factories, right? Everyone makes fantasy, and the whole goal of trying to sort of build stuff in small feedback cycles, tighten feedback cycles, is to actually get data to make these decisions, not based on estimates, right? You should, if you're doing this well, you have a good causal model, right? You actually can say that this is the thing that will move, or we have data to show, right? That when I change this feature, it actually cost people more people to buy, right?
Yeah.
I'm not saying that it's true in every industry. Some industries is really hard to do, right? If you're enterprise sales, it's very hard. There's a lot of like things in front of you, which makes it hard to sort of even say this feature will be valuable, right? It's not possible everywhere, right? But ultimately, you have to get in the mindset where we are not sort of promising stuff that we can't deliver or promising based on fantasy. You got to really sort of get the data to measure all those things, right? And those measurements are much more important than measuring productivity, in my opinion, right? Because before you spend money to figure out if your developers are productive, much more important to figure out why your customers are buying what you're buying, right? And then make sure that that data is fed into your decision making, right, all through your cycle, right, and making the cycles into small.
Okay. No, very helpful. So let's assume for a minute that the engineering leader in our discussion is able to connect the dots and make the economic value connection, which is nonlinear, but they're able to do that, and based on that, the overall team productivity is managed better. Does any of this change in context of this recent, back and forth between work from home versus come into office? Distributed teams have become way more common post-COVID, but then still there is a desire to bring them back into office. Does any of this any of this discussion change in
My
context of whether it's remote or not?
my sense is that there are sort of orthogonal questions, right? I think that if you actually understand how your ecosystem works and how your actually engineering teams are adding value, then you have to have a fairly strong reason why being in the office itself is better, right? I think a lot of this is driven by kind of management culture, where management is still very much output activity throughput focused, right, rather than outcome focused, right? They are much more interested in making sure that people are working, they're busy, they're active, right? And then granted, in COVID, there was a lot of less visibility and so on and so forth. So people got used to sort of maybe having the connection between those two things be sort of loose, right? Overall, I think if you are doing an RTO mandate, right,
Mm-hmm.
um, I don't know that it'll really sort of improve productivity if you're talking about productivity the way we are talking about it, right? I mean, I don't see the causal relationship between the two, right? If you're not doing any others, then it won't matter one way or the other. So I think it's orthogonal. I mean, I think that's a different notion of productivity. It's not just productivity.
Fair enough. All right, let's switch gears in the interest of time. Let's touch on this other hot topic, which is use of AI tools, the developers using Copilot. What's your viewpoint how that plays into improving the team level and overall individual or team level productivity? Where is that?
I think the so AI is interesting. Like personally, I would not want to go back to a world where I started with a blank screen and started typing code. I mean, that's just not fun anymore, right? I think AI has fundamentally changed how engineers just produce code, right? And some people are don't need it. Some people be very highly productive with it. Some people, in the long term, you will end up, if you don't understand how to use these tools, you'll end up being kind of a less desirable engineer in your team. So I think in terms of like individual task completion times, right, being able to do a lot of the sort of grunt work that you would not otherwise have done in the interest of time, right? I think the biggest benefit from AI is in the near term, right? In the near term, long term, I can't, nobody can tell what it is going to be. Near term is that in the same amount of time, it is possible to produce much higher quality code, even with maybe less experienced developers, right? In the hands of experienced developers, that's definitely true, right? I think that the the thing that people I think look at AI is, okay, we can actually get stuff done faster, right? I think the real value proposition is can get higher quality stuff done, in about the same time frame, because a lot of the code that's written by humans today is extremely low quality because it doesn't do testing, it doesn't do documentation, it doesn't do sort of maintenance work, right? And I think that it definitely has the ability to sort of save time, but time savings to me is not a particularly interesting thing. What do you do with that time saved, right? That's more interesting to me. Most of the people, most of the tests that we see, they basically say, yeah, I mean, I'm able to save 10% on task time, and engineers save 4.5 hours a week. Yes, what happened with that 4.5 hours, right? That were they using that to serve the internet, or were they actually did they actually give you something that's more valuable? To me, that's where the trade-off is, right? So there are some use cases certainly emerging right now. Early prototyping, writing a one-off tools, AI is just superb at that. It's really great, right? Writing documentation, debugging code is great, right? Generating unit tests to a certain extent, if you're very careful, right? It is useful, right? Long tail work, code reviews, upgrading dependencies on libraries and stuff like that. Really grunt work that is mechanical stuff that you can do. It does a much better job than I would have imagined even a couple of years ago, right? So I think those kind of long tail work is going to be very much taken over by AI, right? Specialist work, I think, will get taken over more, right? So if I have, not every team is going to need, your uh, specialist front end engineer that they only do is front end, right? You're going to need engineers who understand the domain, who can actually do kind of work across the stack. Because if I don't know front end, then the AI tool is going to help me do that. I'm a primary backend guy, right? And I find myself doing a lot more front end work now because it's just easier, right? All I need to do is understand kind of how to verify whether it's right or not, right? So I think that in a way that is very useful because it actually will reduce the amount of cognitive load that any individual has to bear, right? So I think those are all positive use cases. What I don't know is, will any of this matter in terms of team level productivity, right? I mean, collaboration, communication, understanding what to work on. Are we working on the right problems? Those are still the problem, right? I think if AI is not going to help us there, I don't know. I don't think so yet. So.
What about there's one, I'm going to transition to taking a few questions now. One question is, the tech debt that seems to get produced by the code written by AI. Have you run into this issue, and how do the tech debt issue created by AI written code?
No, I think it is inevitable if you take the easy way out, right? Because clearly hallucinations are a problem. I mean, AI does make code is almost always somewhat wrong, right? It's a question of how wrong it is, right? You have to tweak it. You got to watch it carefully, right? So I think that if you have kind of a clear philosophy on what good architecture is, what good code looks like, you can definitely, in the hands of a good engineer, you can create AI, produce code, integrate AI, produce code onto the main line without creating tech debt, right? But yeah, if you have people just, taking a Jira ticket and putting it into a Copilot and saying, "Hey, generate the code for me," and then commit that code, yeah, sure, you'll get that done, right? So it's not the technology. I think it's the people who use it, right? And what they bring to the table that matters.
Let's take one final question since we have just about a minute. So if engineering team, a team, let's say, as an example, is trying to adopt AI tools to improve their productivity overall, what's the highest leverage point? I mean, is it Copilot for writing code? Is it code review and PR reviews? What would you recommend the starting point? Obvious high leverage AI tool for improving software team productivity.
I don't know the answer to that. I don't have a clear idea, right? I think that, like I said, I mean, most of us have been using this only for like, a year and a half, right? And at most, I think that clearly copilots are essential. I mean, I think that in IDE copilot of some sort, whether you use GitHub Copilot or Aider or anything like that, right? I think they are very useful, right? I think automated code reviews, maybe, right? I mean, ultimately you want to sort of get out of this asynchronous PR workflows anyway, right? But if in fact, because of AI, we might end up having to do more PRs because the code is untrusted. More untrusted code is going into the system, right? So, I think that we have to experiment. I don't want to say, use everybody get Copilot. I don't know enough to say that. So I think that, I think you have to be open. I think one of the things I think is you have to be open to experiment with this technology. I think, people, this is not a great top-down adoption technique. Because if you're interested in sort of measuring time saved and stuff like that, yeah, sure. I mean, make everybody do it, measure the time saved, look at the number of completions accepted. There's metrics, that kind of pseudo productivity metrics. But they're not like Satya Nadella said recently about models in AI, right? I mean, it's not about benchmarking the models, right? It's did you actually end up creating growth in the economy, right? That's when the real impact of AI comes. So the same thing's true. Is it driving revenues? Are you cutting down costs? Are you able to get, is that time saved going into something that you can actually say, okay, I spent $8 million on the AI. Did that AI pay off in terms of more revenues, more costs, right? I think that's the real question. And we don't know the answer to that. I think anybody who says they know the answer to that, I don't know. Maybe they know more than I do. So that's all I can say.
Sounds good. Well, thank you, Krishna. We're out of time. We could probably carry on for another hour or so on these topics, but I think we should respect audience time and your time, most importantly. Thank you for coming on and discussing this murky topic of software team productivity and how AI is helping. And I know we're early in the cycle. So thanks again. And thanks everybody who was able to join us today. We'll make a recording of this, and some people wanted to listen to it offline. So we'll make it available this week. Okay.
Thanks for having me on, Hemant. It's a pleasure.
Absolutely. Thank you.